over the last example, example 5, our real life example, using the properties of logarithms. So let's read it together on page 495. Example 5. The loudness L of a sound in decibels is related to the intensity I of the sound in watts per square meter. By the equation, L equals 10 log I divided by I sub 0, where I sub 0 is the intensity of 10 to the negative 12 watts per square meter, corresponding roughly to the faintest sound that can be heard by humans. All right, so A asks, two roommates each play their stereos at an intensity of 10 to the negative 5 watts per square meter. How much louder is the music when both stereos are playing compared with when just one stereo is playing? And then B, they want us to generalize the result from part A using I for the intensity of each stereo. And you can see like that little box there off to the right, there's decibel levels and examples of the sounds that produce those decibel levels. All right, so and I guess we're trying to figure out how many decibels this is going to end up being. I guess that's what it is, or maybe it's just the the loudness. Okay, I believe that's going to be in decibels. All right, so so we're basically going to try to figure out the loudness of what it would be like, the difference in loudness between two stereos. So loudness sub 2 minus loudness sub 1, one stereo. All right, so we're going to basically do this equation for two stereos and subtract it for one stereo. All right, so it turns out that what we're going to do then is going to be, this is going to be equal to 10 log. Now, each stereo produces 10 to the minus 5, but we got two of these stereos, so it's 2 times 10 to the minus 5 divided by 10 to the negative 12. Okay, so they told us I sub 0 was 10 to the negative 12. Right, and they told us that one of these stereos was 10 to the negative 5, but we got two of these guys. And we're going to subtract that from the loudness of just one stereo. So this is the same formula again, except of multiplying by 2, it's just going to be 10 to the negative 5 divided by 10 to the negative 12. All right, so now what we want to do is we want to simplify things a little bit. And so we're going to get 10 log, and by the way, this is all base 10, 2 times, okay, and let's simplify this. What is, 10 to the negative 5 divided by 10 to the negative 12? If I move this upstairs, it becomes positive 12 minus 5. So this is 10 to the 7th power, right? Minus 10, minus 10 log, and again, this is going to be 10 to the 7th power. All right, now can I simplify this a little bit more? Well, I notice I get 10 in both of these things, both of these expressions or terms, and I'm going to factor that out. So now I got log 2 times 10 to the 7th minus log 10 to the 7th. All right, now let's think about our properties, right? What can we do here? So we've got this product here, right here, and I can expand this, and I get 10 times log 2 plus log 10 to the 7th power minus log 10 to the 7th power. All right, so what's going on here? I notice that these guys right here just cancel each other out, and this ends up with 10 times log 2. And if you put that in your calculator, you're going to end up with, let's just do it, 10 times log of 2, around 3. And so this is going to be this sound. So in other words, having one stereo, I'm having two stereos versus one stereo is going to end up being 3 decibels louder. I know it seems kind of odd when I look at the fact that decibel level 10 is a rustling leaf. I don't know. I don't really quite understand this, but that's what it's saying. I guess it's 3 decibels louder. It doesn't have to do with how loud it is specifically. It just has to do with how much louder it is. Let's see. Conversational speech is 60. Maybe I think maybe loud stereo could be maybe city traffic like 70. Maybe something like that. So maybe it's a difference between 70 and 73, having one stereo versus two stereos, possibly. All right, now the second part of this is they're asking us to generalize this. So, instead of talking specifically about, an actual stereo, they're just saying what's the increase in loudness, just using intensity of any sort of loudness, okay? So we're just going to use, it's the same formula. It's still, for two stereos versus, I guess one still, but I guess they're just making it, they're not going to tell us how much it is. So it's just saying, all right, so 10, you're just using the formula again, 10 log, the intensity is 2 times I, okay, and divided by 10 to the negative 12 minus 10 log just the intensity of 1, still divided by 10 to the negative 12. And it's going to work out very similarly to what the other one did. You're going to factor out the 10. You're going to get log 2I times 10 to the negative 12 minus log I divided by 10 to the negative 12. And then you're going to use your property here on this logarithm by expanding it. So you get log 2 plus log I over 10 to the negative 12 minus log I over 10 to the negative 12. Again, these two terms cancel out. And you're still going to get, this is generalized, log 2. It turns out to be just the same thing, 3 decibels louder. Again, the sound is about 3 decibel louder. This result tells you that the loudness increases by 3 decibels when both stereos are played regardless of the intensity of each stereo individually. So it doesn't matter how loud it is. It's the two stereos are going to produce, there's going to be an extra 3 decibels for two stereos versus just one stereo. All right, so now I think you are equipped to do the real life problem in the homework.